Alright, here's a do now. We have one problem. A ball is thrown vertically up with an initial velocity of 128 feet per second. The ball's height after t seconds is given by this equation. And then we have all of these that need to be answered. So go ahead and pause the video and see how much you can get done by yourself. So, to find out at what time the velocity is zero, you have to use the derivative. Here's the thing. This is a position function. And we said before that the derivative of a position function equals velocity. So let's take this derivative. So it gives us an option to do it with any method. I went ahead and just did it the first method that we kind of learned. Of course, if you know the power method, we know what this answer is going to be. It's going to be 128 minus 32t. But you know my relationship with limits. I love them. Anyways, let's go ahead and do it this way. So, let's see what I did. I went ahead and just factored in the 128, factored through. I foiled this bad boy, and then I didn't actually factor the 16. I went ahead and left it the way it is. And I canceled stuff out. So the 128t cancels out the negative 128t. The 16t squared will cancel out the negative 16t squared when the 16 is being multiplied in. And now we can cancel out the h. So this h is going to cancel out this h, it's going to cancel out this h, it's going to cancel out one of those bad boys, and that's it. So when you now let h approach 0, your derivative is going to be 128 minus 16 times 2t, which is negative 32t, just like we set up here. So we have a derivative. Now when does it equal 0? So I went ahead and subtracted 128 on both sides, giving us the negative 128 on the right side. Divided both sides by negative 32, and that gave us 4 seconds. Please make sure to keep units in mind, because up there, remember, it did tell you that we had t being in seconds. Now they want to ask, what is the height of the ball at the time velocity was 0? We said 4 seconds. Plug in 4 into this equation. You get 256 feet. Estimate the instantaneous rate of change at t equals 3 by seconds by using the limit process. Alrighty, so we have estimates. We can always get more and more accurate, but we ended up getting this right here. And it said find the instantaneous rate of change using the limit process. So you actually have to find the derivative. So we found the derivative using the limit process before. It was, if I remember correctly, it was 128 minus 32t. So t equaling 3 would be would end up giving you 32 feet per second. Just plug in 3 into the derivative. And then the last question, let's go ahead and bring that up. When does the ball hit the ground? Alrighty. Ignoring air resistance, I mean, this is coming from my physics background, but ignoring air resistance and knowing how things work, if you throw something up, it's almost a perfect parabola if you ignore air resistance. Then, since the ball reaches the maximum height at 4 seconds, and that I know that because that's when the velocity is 0, then the total time for it to actually hit the ground will be just twice that distance. You know, the way the ball moves up is the same way it comes down. But mathematically, you simply have to take your original equation and make that equal to 0. And the best way to do it is by getting the greatest common factor, and then letting this equal 0 will tell you when it was on the ground the first time around. It was at 0 seconds, and there should be S for seconds. And then the next time, letting this equal to 0, that will tell you when the ball was 0 the second time around, and that's the number we're looking for. It's 8 seconds. So when you factor and you end up with a 0, that's just because that's where the ball started. So do not use that as an equation. No! When does the ball hit the ground? The ball hits the ground at 8 seconds. Let's get some definitions as well. So here's the definitions of derivative. We already talked about this, so you already have it in your notes. And geometric interpretation of derivative, the slope of a tangent line to the graph of a function at that point. Instantaneous rate of change. Here's an example. Let's say you have f of x equaling x squared. You simply plug it in. By the way, you don't have to write this down. We already covered this. This is just a little reminder. According to our previous definition, we can find the derivative by plugging it into the previous equation. So where there used to be an x, you put an x plus h. And then you try to get it to a point where the h's cancel, so the denominator no longer equals 0, and you find your derivative, which is 2x. Here will be another example. For this one, we dealt with x cubed plus 2x. Find the derivative of that one. Same process, and then you, it's a little bit troublesome because you're gonna have to deal with this guy right here. But things will work out, and you're gonna end up getting a derivative right here. Again, don't write this down. Just enjoy the video. Now, we get to the point where we get to learn the power. I think this one's the power rule that we're going to be talking about. So students will use a power rule to find the derivative of a power function. So power rule is this. Let's say f of x equals x to the n power. Then the derivative is n times x to the n minus 1. You take that n, put it right there, subtract 1 from it, and then good things will happen. So, here's an example. What's the slope of the tangent line to the curve x squared plus 3x minus 1 at this point right here? So, you take your derivative, you take that 2, let me use a different thing. You take that 2, put it up front, which is right here. That becomes now x. You take that 1, put up front, so 3 times 1 is just 3, and that's x to 0, which just becomes 1. And that guy just goes away. Constants, no. No constants. Alrighty. So you have your derivative, you plug in this guy, and you end up with 5. So here you have it. Now, we didn't need the entire point, we only needed the x coordinate, but why not know that this happens at y equals 3, huh? It is problems like this where you're thinking to yourself, oh my god, I love your power rule. If I had to do the limit, where that involves an x to the 7, then You know, regular schools have just a belt. We have horses. Anyways, you take that 7, move it up front. So 5, let me use a different color. 5 times 7 is 35. Highlighter, come on. So that's why that we have a 35. 3 times 11, that's negative 33. And then 1 times 12, that's 12. That 7 becomes a 6 now. That 3 becomes a 2. And that x to the 1 power becomes 0, which is why the x just goes away. And then at negative 47, no. So now we're looking for f prime of x. That's what we have. That's f prime of x. Now, since we're asking about what's f prime of 1, you plug in 1 into this bad boy, which gives you 14. Your slope of the tangent line at x equals 14, at x equals 1, is 14. Here we have another example. We're trying to find the derivative of this time a radical function, in which case you change the radical into a power function, and then you subtract 1. You of course put the 1/2 up front first. 1/2 minus 1 is negative 1/2, which brings your stuff to the bottom denominator. So you have from the bottom, you have that 2, because that's in the bottom of this fraction. And this part went to the bottom because of the negative exponent, leaving you with this. Are we done though? No. Make sure you have it all in radical form. Now some teachers don't like that still because they don't like radicals on the bottom. So you potentially have to multiply top and bottom by radical x. So you would end up with radical x over 2 times x. But that's not why we're here. We're trying to find out what the slope is at this point. So we first plug it into our derivative to get this slope, and then do it again when we have this point, which is 4. So our slope at 1 is 1/2, our slope at 4 is 1/4. What that means is, if you were to put a tangent line at this point, the slope for that tangent line would be 1/2. The slope of the tangent line at that point would be 1/4. Look at this. Do you know what this means? That's the same thing as saying f prime. F prime, really, assuming this is like f of x, right? F prime of f of x is simply d f of x, of dx. That's the same language. So in this case, what we're doing is we're taking the function, which in this case is just this, and we are applying this part to it. So right here, we're asking for the derivative of 7 over the 5th root of x to the 4th. We do the same thing that we usually do. We take it, we turn it into a power thing, and then we probably want to move it to the top. And when you have it on top, that's when you subtract 1 from it. You also, prior to subtracting 1, you want to multiply the negative 4 over 5 by 7, which is negative 28 over 5. Negative 4 over 5 minus 1 is negative 9 over 5. And from here, you have your derivative. Alrighty. Now, just want to reiterate. The reason why this means the same as this is because if I was to take out, make sure I have the right color, if I was to take out d of x, then it would look like d of x of f of x. That's pretty much what this would look like if I was to just write it a little differently. And instead of f of x, all they did was, whoops, that's not the highlighter. They just, instead of f of x, just plugged in what the function actually is. This one is a simple one to talk about. We have a constant at 7 to the 5th. You do not apply the power rule here. This is just a number. Since this is just a number, the derivative of a number will always be 0. A particle moves along the x-axis so that its position is given by x of t equals 2t. Let me get rid of this music. Okay, there we go. X of t equals 2t to the 3rd minus 21t squared plus 72t minus 53. So what's the instantaneous rate, which is derivative, of change of the particle at t1? We're going to take the derivative of this function, and then we're going to plug in 1 into it. So let's look at each one individually. 2t cubed, that's going to be 6t squared, boom. 21t squared, that's going to be 2 times 21, 42t, boom, but there's a negative, so negative 42t. And then 72t is just 72. You plug in 1, and you get your answer, which is 36. There you have it. I will see you guys tomorrow. Have a good day.